restoration unit, and he's got a couple of his STEM mates here who are going to help us.
We have Betty, Leno, or Cat went here. Oh, Cat is down there. so they, during our off season, help take care of the nursery here, and then also will eventually help with the outplanting. And then during our spring and summer programming, they're also the educators. So they guide the participants around for a week-long experience where it's involved going out snorkeling out to Lou Key or Newfound Harbor. We're going out tagging mahi or sharks. We're working in the coral nursery with the scouts, going down to Key West. It's quite an extensive week. And at the end of the week, they pick a topic at the beginning and they work on a poster board or a PowerPoint, and they present to the other STEM crews that are on site at the end of the week, like you would at a conference and things like that. And they're also working on building ROVs, and they race them at the end of the week as well. So it's quite a bit. And a lot of the work that they are doing is either helping the expansion of the nursery, or they're collecting data for other organizations like Bleach Watch with Marine Lab. They go out and do surveys. They do stony coral tissue loss disease surveys. And then again, the tagging of the sharks and the mahi, that all gets sent out to various organizations as well.
So there's usually two kinds of saws to use. A lot of times if you're getting corals from the wild to start, it may be on a base or a skeletal part, and you have to saw it off. This saw is, more delicate, so you can get a typical hardware store tile saw. You just have to have something where it has a ability to have water in it that will keep cooling the saw down, and we put salt water in it, so it's actually tough to keep this from corroding later. So it's more of a cleaning process, rinsing process afterwards. You can also use some spray pan with olive oil to spray it down some of the metal parts so it doesn't rust, because usually these don't last too long, and they're not too cheap. They're about $500 or $600 range, but so is the Gryphon saw. And in fact, there are so many people starting to do, whether it's arts and crafts or coral restoration. These are in high demand now. There's about a 6-week wait for them. But you can get them in 110 volt or 220 if you're in a country that's 220 electricity. You can buy either one. And usually, like in our CRUs, we'll put 2 of these in there and about 4 replacement parts. These also are making mostly out of stainless steel and plastic. They also have a well for salt water to be in the bottom that keeps it cool. And we have to change it out pretty often because that water will get milky. So let's say you brought in some corals from the wild and they were on literally their own skeleton. That saw would be hard, so you can be able to use something big to maybe slice down pieces, then cut them off the top. So I like to use the analogy, it's like a birthday cake. You got this part is the cake, and this part is the icing on the top. So the icing is the living tissue, that's what you want, and you need a little bit of the cake to hold it on there. You don't want that much cake, because imagine making one that's sticking way up in the air. And it's the same thing even with the plugs. We'll use one of these after we get one that's fully, and we'll saw it off the plug. And we might use something like this to quickly saw a number of them off. That one will do it, but it'll take some time. So if you're just making a couple cuts, you don't need to get the big saw out. But if you're going to do a day of cutting and you're going to make a lot of these, first just slice it off. Take enough so that it has a thin wafer, so that's easy to cut on that saw. But it also means you can reuse this plug one more time, maybe 2 more times, depending on how good you are on the cuts. One of the biggest things you'll see is these, remember, corals are 3 different organisms, 3 different phyla, 3 different kingdoms of organisms. They're part animal polyp, they're part algal plant, and they're part microbial community. The microbial community, it's is the mucus on the outside, and it doesn't sound like much. But nowadays, humans have already found out that we have a micro-community, a microbiome inside our gut, sort of on the surface of our intestines. And that does the same thing. It helps add nutrition, it helps keep other organisms away. If you get a bad infection of the wrong kind of bacteria, that's when you get sick and have to maybe use some yogurt to get some better, less benign, more benign organisms in there. Same thing here, except it's like an inside-out intestine. So those little villi in your intestine is like the tentacles, which has the mucus on the outside rather than the mucus on the inside of the intestine. And one of the first things that happens in stress is it's stimulated to produce a lot of mucus. And so we use something as high-tech as a turkey baster, and we try to keep pushing that mucus off. Think of it like an operation. If you were a doctor and you were doing an operation and you started bleeding and stuff like that, you'd be constantly cleaning that wound, constantly, sponge, drainage, rinse, all it, and we do exactly the same thing. Because what will happen is that's where the bad bacteria will grow, is on that mucus. And the sequence here is actually a sequence of stages. So the person cutting will cut and put them into one of these bins. The next person, this works great with a partnership. The next person will take a baster and start, as soon as they get that mucus, they'll start just basting it. This will be underwater. You're just puffing it like a puffer fish may do. You're not pushing them around on the bottom, and you're not doing it so delicate, but you'll see when it pushes the mucus off. The mucus will quickly pick up some of the cut calcium carbonate of its skeleton. It'll also start picking up bacteria, and that's what you want to keep getting off. And the better you do that, the better health of the recovery. And then they go into here, and that's the recovery area. Again, you see there's no light or less light. Basically, anyway, I'll pass this one around because you'll see a couple of things. One is the it's just nice to see, the coral lights on here. This is probably not as good a one as one of the big polyps, but you hear people talk about don't touch a coral, and it's not because of pressure. They can take some or as much bacterial, but the polyp is literally, the analogy is like a cup full of jello sitting in a cement cup that is made up of razor blades on the inside. So if you look in here, you'll see they have, each polyp sits in and makes its own calcium carbonate. It sits inside there, and as it grows, it literally steps up on its tippy toes and forms a new floor and gets bigger. And then it gets bigger and gets bigger. And when they're too close, they make two so that they can spread out this way, which is why a lot of the mounding coral turns into a nice big boulder. However, if you're sitting as a jello inside something that turns out to be, the analogy I give is, those things, if you have a hard-boiled egg and you want to slice it in a slicer and it has these little wires, and you don't have to push like you would cutting wood. You just easily push it, and that wire goes through a nice, soft or hard-boiled egg. The same thing here. I'll pass this around, but picture that polyp sitting in these things that it makes, brand new, pointy, sharp like a razor blade, and if you touch the top of it, you might think, I'm hardly touching that thing. But then you realize that you're pushing it down against, it's standing on razor blades. And so what happens, it's really death by 100 cuts. And so that's why you don't touch or stand on corals. It's not because you think, they're not tough, and I stood on them, I looked, they seem fine, but maybe the next day they're not fine. So we can hold and touch, but we can't put pressure on these things. So that's why a lot of times we'll like to do the cutting or the planting when it still has a little rim of some of the calcium. So you can hold it from the outside like this and be planting, not pushing down this way. Now, we'll do a lot of touching here, but just be a little bit careful. You'll see on this thing, there's other organisms like called they're not exciting bivalves because they're called boring bivalves.
Knee slapper.
But they bore in at an early age, and you'll see that that's what makes a honeycomb, literally, and that's what some of those openings of 2 siphons you see at the top. But you can see how these things grow, is they grow literally growing up like a tree, showing the rings behind it. And they're down at the Eco Discovery Center, which still isn't open, but it's supposed to open soon. They have a core that's something like 15 feet tall from a coral, and it has then, here's where Columbus landed, here's where prehistoric, and the lines on those rings of the corals.
Wow.
Of when that happened. That's why something the size of this room could be 1,000 years old. So you could have had, seen Columbus landing to Ace, or a fire or a volcano go off in the 1400s or something like that.
It's pretty cool.
Okay, so this is the knobby brain coral, and you can see on